All right, I kind of want to go over distance versus displacement again because again the period was cut short. I do want to make sure people understand everything that's going on here. All right, so let's take a look at this do now question. So this do now question says you travel a total distance of 5 meters, but you only ended up 1 meter from where you started. How is this possible, right? So you go up 5 meters, and then, oh, rather not go up 5 meters, but you can go up 3 meters and then go back down 2 meters, and then, well, you're 1 meter from where you started. Or alternatively, you could go around in a circle, right? You could have traveled 5 meters, but your distance from where you started, right? You ended up here at the end of that path, started there. Well, that distance could have been 1 meter. And any other variation you guys can think of. Now, in physics, you'll learn the difference between two terms, right? So there's one term called a scalar and the other term called a vector. And so a vector has a very specific definition, right? So the difference between these two terms is that, well, one has a direction and the other does not. So a scalar are quantities that only have magnitude, and magnitude just really consists of a number and a unit. Right, so something like 5 meters, 6 kilograms, 7 degrees Celsius, that would be considered a scalar. Whereas vectors, on the other hand, vectors have both, are quantities with both magnitude and direction. Right, so saying something like 5 meters east, 8 meters to the left, 5 meters west, those would be considered vectors. So anything with a direction is considered a vector. I know some of you guys don't know what a magnitude is yet, but again, magnitude is just basically a number, a size of something. And so here you were asked to classify things as either scalar or vector, right? So again, scalars do not have direction, whereas vectors do. You'll see here that 5 meters per second is a scalar quantity. 32 degrees Celsius has no direction, it's a scalar. Here you see a direction, so that's a vector. Here, no direction, scalar, and then you can pretty much guess the rest, right? This is direction, that's vector. This direction, vector. All right. So here are two things you'll learn. There are distance and displacement. So distance is essentially, well, your total distance traveled in a path. Right, so if I were to travel 600 meters this way, right, 600 meters this way, and then 240 meters this way, well, 600 plus 240 meters would give me 840. Right, it would give me 840 meters there. Now, alternatively, displacement, on the other hand, you care where you are. Displacement is essentially your final position minus your initial position, which is displacement. Displacement is how far you are from your initial starting position. You don't care about the fact that you went east and then north. You don't care about that. You just care about, well, where did you end up? So distance, because distance, you care about just your total length traveled regardless of distance, regardless of direction. Distance is a scalar quantity. Displacement, on the other hand, displacement is essentially a vector quantity because you want to know where you are in relation to where you started, right? If I say, well, I'm 220 meters from where I started, right? So let's say I ended up here and this is 220 meters from where I started. Do I exactly know where I started? I could be here, right? This could be 220 meters. This could be 220 meters. This could be 220 meters. You need a direction, right? So is it north of where you started, right? Is it south of where you started? Is it east of where you started? So displacement is a vector quantity here. Displacement requires direction. So let's do 4A. 4A, right? 4A, hiker walks 5 kilometers due north, 7 kilometers due east. What is your total distance traveled here? 5 plus 7 gives you 12 kilometers. That's your total distance. Done. You need to show work though. Let's move on to a slightly more difficult question. In a drill, a basketball player runs the length of a 30-meter court back. So the most important part in this question is the fact that he runs the court and then runs back. And the court is 30 meters long, which means that he runs 30 meters again backward. So this is the part that tricks students the most. They don't read the fact that this question is saying runs the court and back. So this is one entire time, right? So this is one entire time, which is 60 meters. And so the player does this 3 times in 60 seconds. Right? So he does this 2 more times, right? So he does it 3 times in total, which is what I want to say, not 3 times more. He does it 3 times in total. So if he does it 2 more times, well, that's 60 times 3, right? So this is 3 times in total. And then your total distance there traveled is 180 meters. All right. A baseball player runs 27.4 meters from the batter's box. Right? The batter's box is here. Runs to first base. 27.4 meters. Runs past it 3 meters. Runs back again 3 meters. Right? Runs 27.4 meters from the batter's box to first base. He overruns first base by 3 meters, which is what this is right here. Overruns it by 3 meters. And then returns to first base. So he comes back another 3 meters. Now, a lot of students, they kind of ignore this part, right? They kind of ignore the fact that, well, just because there's no number here when he's returning back to first base, well, that doesn't mean that you can just ignore the fact that he does run 3 meters back. He doesn't teleport back to first base. He walks a certain amount of distance. So he runs back another 3 meters. So compared to your total distance traveled, and your total distance traveled is 33.4. You're adding 3 plus 3 plus 27.4. Compared to the total distance traveled by the player, the magnitude of the player's total displacement is what? Right, so your displacement here is, again, how far you are from your initial starting location. Well, you end up at first base. You started at the batter's box. So that means that your displacement right here is 27.4. How does your displacement compare to your distance? Your displacement is 6 meters shorter. And that's how you would solve that question. Here, a sailboat on a lake sails 40 meters north, then sails 40 meters due east. Compared to its original starting position, the new position of the sailboat is what? So again, you end here, you start here, you look at your answer choices. They essentially want the distance, the displacement between the end and the start. So they want to know what D here is. So if you do A squared plus B squared is equal to C squared, right? So 40, right? So this is a Pythagorean theorem you learned in math class. So D squared is right there, right? So this would be B, this would be A, and then this part of the triangle would be C. And then you just solve for D here, okay? Essentially solve for D. If you do run it through a calculator, you get 3200. D squared, square root both sides. And you get 57 meters northeast. And that is D. Alright, let's go on to 5C here. A displacement vector with a magnitude of 20 meters. So here, they're giving you your displacement vector, right? Your displacement vector is 20 meters here, which means that your perpendicular components there, right? So they're asking you to find your sides here. They're asking you to find your sides. So again, we're using the Pythagorean theorem. We know that 20 squared here is 400. So you're essentially saying, well, which one of these answer choices can possibly give me 400? So if you do 10 squared plus 10 squared, you will not get 400, right? So if you do 10 squared plus 10 squared, you're not going to get 400. 16 squared, 256. 8 squared is 64. You're going to get 320. 12 squared is 144. That's 64. That's not going to give you 400. 12 squared is 144. 16 squared is 256. That will actually get you 400. And so the answer here is D. That's it.